Welcome back to the channel. Today I'm going to show you a really cool, cheap, and simple high-performance carburetor hack for the Predator 212cc engine. So some folks may notice that we have the Hemi version of the 212 on our bench. No worries, what I'm going to show you today works the same on both the Hemi and non-Hemi engines. We just happen to have a Hemi on the test bench for no particular reason. So the subject today is carburetors. Now, tuning pretty much any carburetor for the 212cc Predator, whether it's a stock or semi-exotic carburetor, will require disassembling the carburetor and changing the jets a number of times in order to tune the carburetor for your specific needs. Fiddling with the jets can be overwhelming for some people, and I'm not a big fan of it either. So today, I'm going to show you two cheap carburetor options that don't require changing jets, and all you have to do to tune the carburetor is grab a screwdriver and you can adjust the air-fuel mixtures while the engine's running. Easy peasy. So what I'm talking about are these two carburetors, the H60 and the H80. These are replacement carburetors that are made for the Tecumseh snowblower engines. Now, the H60 and the H80 refer to the type of Tecumseh engine and not the actual carburetor. Both the H60 and the H80 engines are old school flatheads that were popular back in the day. Anyway, these older engines are not as popular these days, and most folks like to use the 212cc Predator as a starting point for high performance engine modifications. A few years ago, we did a bunch of simple modifications to one of our Predator engines, and we measured the horsepower on our Prony brake dyno. It turns out the 212cc overhead valve Predator can easily make between 8 and 9 horsepower with simple bolt-on modifications. Plus, it'll make a lot more power with some more complex modifications. Of course, we had to take the carburetor apart many times and try different main jets in order to tweak the engine to make the power we wanted. And like I said, changing jets is no fun. Now today, we're not going to be fooling around with the dyno. Instead, I'm going to show you an alternative to changing jets to simplify carburetor tuning. It turns out the old school carburetors that are used on the Tecumseh engines will fit a Predator engine, and best of all, you don't need to fiddle with the jets anymore. And you can tune the carburetors with just a screwdriver. Well, I lied. Sort of. You see, these carburetors don't really fit the Predator engine, and you're going to need this low-cost adapter kit to make it work. Now, this kit is actually not meant for the Tecumseh type carburetors, and it's intended to be used for a motorcycle type carburetor. No worries, this cheap doohickey is actually almost the perfect fit for our application, and it's going to allow us to bolt the carburetor right onto the 212cc engine. Now, some of you may ask, why not just use the motorcycle carburetor and not bother with the old school Tecumseh type carburetors? Well, that's always an option, but keep in mind if you want to fiddle with the motorcycle carburetors, then you're going to be playing with jets and all that crap. The whole point of today's video is not to fiddle with jets and do the tuning with just a screwdriver, and do it on the cheap. Whoop, whoop, whoop. Skipper has a question already. Now, before I answer Skipper's question, let me tell you who Skipper is. You see, Skipper likes to watch my videos, but he also likes to skip through them, and Skipper never really knows the point of the videos. Well, first of all, don't be a skipper. I recommend watching the whole video and not skipping through the video. So to answer Skipper's question, the point of today's video is to show a high-performance carburetor modification that can be done without having to change jets in order to tune the carburetor. There are, of course, many different carburetor options, and I'm going to stay on topic and show you how to install and tune a carburetor that was made for a Tecumseh engine to work on a Predator engine. Of course, as I mentioned before, this is a cheap option, but it also may be the best. So before we start fooling around with carburetors on our test bench, let me cover some of the basics. Now, if you look around on the Jungle site, you can find a replacement carburetor for the 212cc Predator engine, and some of them actually have this very nice adjustment screw on the side. This is an awesome feature, and you can only find this on replacement carburetors. But this adjustment screw is only for the idle air-fuel mixture, and it allows some adjustment at idle. But the main jet, which is responsible for the fuel mixture under a load, is still not adjustable, and you have to pick and choose from an assortment of fixed jets in order to tune the carburetor to get the engine to run right after you've done some modifications to the engine. Now, the H60 carburetor also has an idle mixture adjustment, and down here it has the main jet adjustment, so that means you don't have to deal with changing jets. Instead, all you have to do is tweak this bottom screw for your main jet adjustment. Not too shabby. So the stock Predator carburetor measures in at 19mm, and the H60 carburetor is slightly larger at 21mm, which is nice, and this big dog measures in at a whopping 24mm. Oh, and this guy is $13 and the big dog is $17. Of course, you have to drop another $25 on this adapter kit in order to get these two carburetors to fit the 212cc Predator. Now that's the good news. The bad news is neither one of these carburetors will work directly with the governor. However, this carburetor can be modified to work with the stock governor, and I'll show you how to do that later in the video. The big dog, well, it's a lost cause, and you need to bypass the governor in order to use it. Now, the main reason the stock Predator governor will not work with these carburetors is these two carburetors have a bigger bore size for the throttle plate, and the governor was engineered to work with a 19mm carburetor, and when you swap in the 21 or 24mm carb, the linkage ratio is completely wrong, and that'll make the governor unstable. Now, since this guy has a 2mm bigger throttle, it's possible to get the governor to work, but it's tricky and requires some fabrication. I reckon given enough time, I could get the big dog carburetor to work with the governor, but when you go with something this big, keeping the governor operational is pointless. Now, of course, this video is for entertainment purposes only, and the things that I do can and will destroy the engine. I'm sort of a professional and I have many years of experience, and I know how to do this stuff safely. Did you get that, Skipper? Now, despite the difference in throttle sizes, both the H60 and the H80 have the same size flange, which is awesome. Now, for the best performance, custom-made gaskets should be cut out of some gasket paper. But today we'll use the gaskets that came with the adapter kit. It doesn't fit perfect, but it fits good enough to prove that these carburetors will work. I reckon we need to take the stock carburetor off this engine before we can really try anything. Now, if you missed last week's video, this engine was modified to have two different kinds of ignition systems. It has the stock magneto and it has an adjustable 12-volt ignition system. It's a pretty cool setup, but we won't be fiddling with the ignition timing today. So here's a tip. This governor stuff can be confusing, and whenever fooling with the linkages, it's helpful to take a picture of where the springs and the rods go for easy reassembly. Alright, I guess we'll start with the H60 carburetor first. And as you can see, it doesn't bolt up to the Predator engine, but it will bolt up to this carburetor adapter. The bolt holes between the carburetor flange and this adapter are about a ½ millimeter off, so it's not 100% perfect, but this stuff will go together without any modifications. The adapter gets bolted to the Predator cylinder head with the bolts that were supplied with the kit. Now, this nipple came with the kit and it's gonna get in the way, so we'll have to get rid of it and use the plug that also came with the kit. The optional plug needs to be wrapped with some Teflon tape to make a leak-free plug. It's too bad the nipple gets in the way because it will come in handy in some future experiments. You know, I may drill and tap the adapter in the future to put this nipple on the bottom if I need to. The M6 studs that came with the kit seem to be a bit on the long side, and they should be cut down, but they'll work on the H60 carburetor if you're lazy. Now on the big dog H80 carburetor, the left stud won't work, and the left stud needs to be replaced with an M6 by 20mm Allen bolt. Actually, it's a lot easier to use the M6 by 20mm Allen bolt on both the H60 and the H80 carburetors. Alright, let's see how this engine runs with the H60 carburetor. Okay, well, I was not prepared for this, and right out of the box, the carburetor seems to be adjusted pretty close. Interesting. The idle's a bit high, so we'll need to drop it a bit. Well, shucks, let me stop the video for a second. So, I was having way too much fun and I wasn't looking at the tachometer. Well, it turns out this cloud of fog coming out of the carburetor is not the fault of the carburetor. Nope, you see, the throttle response is wicked fast, and the engine hits almost 5,200 RPM instantly. So, what we're seeing is the result of the valves floating and the intake charges being pushed back out of the carburetor. It's not good for the engine. Now, valve float happens when the valve springs cannot push the valves back into the closed position quick enough, and that's because the engine's spinning way too fast. It took me a while to figure this out, So you'll see this fog a few times throughout the video before I realize what's going on. Now it needs to be mentioned that overspeeding an engine will throw a rod eventually. However, there's been instances where the flywheel explodes as well. You know, a billet rod and a billet flywheel are definitely needed if the engine's going to be operating above 4,000 RPM. Throwing a rod is pretty bad. However, an exploding flywheel is really bad. Alright, back to the video. Okay, let's take care of that idle. And that's better. Now this is the idle mixture screw, and generally you want to adjust it back and forth until you achieve the highest idle. Don't worry if the idle goes up. You can go back and adjust the idle screw to drop the idle once you get the mixture screw adjusted. Now this guy is the main jet and it seems to be okay, but I'm going to turn it out slightly to enrich in the mixture. Now when I goose the throttle, you can hear the engine's running really rich just by the sound of it. So now all I have to do is turn the screw in a tiny amount and boom, we're in the zone again. Of course the fog's coming out of the carburetor is not a carb issue. Now doing this on the bench will get the settings real close. However, ultimately the engine has to be under a load and you would adjust for best throttle response during acceleration. So adjusting the carburetor is sort of like a dance, and you may have to fiddle with the idle mixture, the idle, the main jet, and each time you'll get closer and closer to the ideal setting. So I'm real happy with the smaller H60 carburetor, and from what I can tell, there's plenty of adjustment in both directions to make this carburetor a serious contender. Alright, let's give the H80 Big Dog a try. This carburetor has the larger 24mm throttle and is made for a 10 horsepower Tecumseh engine. Now, the larger throttle is helpful for more power at full throttle, but sometimes there's issues with idling with a large carburetor. Plus, we really should be running a free-flowing exhaust header to take full advantage of this bigger carburetor. Just for fun, let's see how it does with the stock exhaust system. Alright, it started right up, but it seems like we're way out of adjustment. So I'm going to start with slightly raising the idle, and that'll give me some headroom for all the other adjustments. Alright, the dance begins, and now I can adjust the idle air-fuel mix. And then some more idle adjustment. And then we can do a slight tweak of the main jet. So I got confused and I was trying to adjust the main jet while not realizing what I'm hearing is valve float. So this is when I realized what was going on, and the fog that was coming out of the carburetor was because of valve float. So back to the dance and a little bit of idle mixture, followed by idle adjustment again. And then some more idle mixture. And then some more idle adjustment. This goes on for a while. So apparently the engine mounts on the test stand have loosened up and now we have a lot of shaking, which also confused me. Anyway, I did get the engine to idle nicely. So the Big Dog H80 carburetor works, but it really wants a freer flowing exhaust. The carburetor is a bit too radical to use on a completely stock engine, but I did get it to idle. I reckon something like this really needs to be on a go-kart or a mini bike to get it tuned in just right. So let's take a look at the baseline adjustments to get these carburetors to work. Now, these numbers are based on my test bench tuning and should be close to ideal for a stock engine. A modified engine would require some minor tweaking. So on the H60 carburetor, the idle mixture screw wants to be a half turn out and the main jet wants to be 1.5 turns out. Now on the big dog, the idle mixture wants to be 1 3/4 turns out and the main jet needs to be about 1 turn out. Now the engine idle speed was adjusted to as low as it would go before the compression relief mechanism kicked in. These Predator engines don't idle real low, and that's due to the compression relief gizmo on the camshaft. Anyway, the H60 carburetor is what I'm going to be focusing on for some benchtop experiments that we have planned in the future, and we need to make this guy play nice with the governor. Alright, the carburetors work, and we've proven that on the bench. So if the carburetors are to be used without the governor, well, we're good to go. The following discussion is completely unnecessary unless you want to understand the complexity of how I got the governor to work with the H60 carburetor. And like I said, none of this is necessary if the governor is bypassed. So the throttle on the Predator engine is directly controlled by the governor. Now on the stock 19mm carburetor, when the throttle opens a little bit, that will of course speed up the engine and the governor will automatically control the throttle to any desired engine speed. And that's a good thing about governors. Now when we install a carburetor with a bigger throttle, well, things get a little bit out of whack and the stock governor tries to regulate the engine speed, but with the bigger throttle, the regulation becomes unstable. In the industry, we call this hysteresis, and that means the feedback is overcompensating. Now, I'm no expert in mechanical feedback systems, and my expertise is in electronic feedback systems. Anyway, hysteresis is something that can be dealt with in the software by tweaking the numbers in the PID. PID is proportional integral derivative, and it's a very deep and extremely complex subject, so we won't get into it. However, I will apply my knowledge on the subject to modify the mechanical feedback system that we're dealing with. Most people never give a second thought to how the governor works and the complex mechanism involved in regulating the engine speed. Ripping out the governor and tossing it in the garbage is typically what happens. Today, we're going to give some respect to this evil device because they do have a purpose. So this arm on the stock Predator governor is just part of the linkage. The actual governor lives inside the crankcase and it's composed of these parts. This gear meshes with the gear on the crankshaft, and that's how the governor gets its engine speed reference. Now as the engine speed increases, these black doohickeys will push this nylon button in this direction, and through a series of linkages, this will regulate the throttle to hold the engine at a constant speed with a variable load. Now this simplified plastic gizmo is a version of the flyball governor that was used on steam engines back in the day. So yeah, this is a flyball governor, and it's very complex. So when this shaft spins, the centrifugal force will cause these balls to expand outward, and that'll move this linkage. Now, my point in showing you this stuff is to help you understand that since this device operates using centrifugal force, the action is nonlinear, or another way of saying it is, the force at the tip of this nub or the force on this linkage is not proportional to the speed of the engine. Nonlinearity is a tough concept to get across, but if you understand math, this is an exponential function. So on this graph is an example of an exponential curve, and this is a linear curve. The force at the tip of this doohickey will follow this curve. The bottom line is, when dealing with this stuff, you can't apply linear logic to a nonlinear problem. So in order to get the governor to work with the H60 carburetor, we have to try and maintain as much of the original geometry in the linkage system and only modify one thing. It's not going to be perfect, but it'll get us in the ballpark. So in this snapshot, I'm showing you how the arm is positioned when the stock carburetor is up against the idle adjustment screw. It's important that we maintain this geometry because if we don't, it's going to upset this guy and we'll have unstable engine speed regulation. So over here, I'm showing how the throttle is up against the idle stop screw and how this linkage fits the carburetor. This point here is the center line of the throttle shaft, and from here to here is the offset that was used on the stock carburetor. If we mimic this exact arrangement, we'll have a slightly unstable throttle. Basically, all we really need to do with the H60 carburetor is build something close to this, but have our linkage offset slightly more, and that'll reduce the hysteresis to the point where we have a stable throttle under various loads. This will have basically the same effect as changing one of the variables in the PID, but in our case with a fully mechanical feedback system, we don't have the luxury of changing a number in the software. Meh, I think in terms of code because that's what I have experience in. Okay, now we have the H60 carburetor in place, and the governor arm geometry is in the same place. This linkage wants to connect to the throttle right about here, and as you can see we have nothing to connect, so we're going to have to build something so we can attach the linkage to the throttle on the carburetor. I went ahead and picked up a box of 5/16 by 1 5/8 fender washers from Menards for a few bucks, and we'll use these washers to build our throttle extension. The idea is to build something like this. This should provide us the offset that we need to properly connect the throttle linkage. Fast forward a bit, I have a completed throttle arm extension. Now in this guy, once I figured out all the basics, then I went ahead and cut away all the unnecessary metal to reduce the mass. Yep, it turns out the mass also has an effect on the governor, and the lighter we can make it, the better it is. Now unfortunately, this throttle extension is an evolutionary design and most of it was built and tested off camera. Basically it's hit and miss, and I had to build a few of these to get it right. The good news is, if you understand all the crap that I was just talking about, ultimately this is the result, and it's just a simple extension that attaches to the throttle arm. Now, from the center line of the throttle shaft to the center line of this hole is 14.8 millimeter. I think if any of you folks made it this far into the video, well, you probably like the sound of my voice and none of this really matters. This stuff is extremely tricky and it requires precision drilling to build. But I was able to do it and I have terrible eyesight. Anyway, this extension screws into the stock throttle arm with M3 by 6 bolts. And I actually put nuts on the backside too. I reckon 440 by 1/4 inch would also work, but I don't have SAE stuff in this size. Now the last thing I need to mention is the stock Predator linkage won't work, and that's because it has no way to clip into the extension arm on the throttle. So I had to fabricate a new linkage and it's almost the same length. It's tough building this stuff and this is the best I could do. Anyway, the new linkage will lock into the throttle extension, and I also made provisions to reuse the spring. Let's give this a shot and see how it works on the test engine. Choke works a little bit too good. Interesting. Alright, a nice stable idle. Let's increase the speed. Nice. The tachometer is indicating 3,700 RPM, which is technically a bit high, but it's the same as the stock carburetor. Seems like we have good speed regulation throughout the range. Let's put a load on the engine. Right here is the load number, and it's in amps that the alternator is putting out. Alright, first we need to turn the alternator on, and we're showing about 6 amps. Now I need to turn on the only working load, and we're showing 28 amp, which is about a 15% load on the stock Predator engine. The RPM dropped a little bit more than I wanted it to, but that's good enough for now. The governor is definitely working, which is great. I may try to get it to regulate a bit better, but first I need to repair the load center so I can see how it regulates under a huge load. This stuff is rattling. So for an air filter, I guess I could use one from a Tecumseh engine, and they're about 35 bucks new. However, I went ahead and repurposed an aftermarket air filter adapter for the Predator engine. This guy had to be modified on the drill press with a mill bit in order to relocate the mounting holes. A job like this is better suited for a mill, and I do have a mill, but for smaller jobs like this one, the drill press is faster. Meh, it could be worse. I'm using 1032 by 1 inch Allen head bolts to mount this to the carburetor. And now I can just slip on the oversized filter that's normally supplied with this adapter. Good enough. Technically, the carburetor should be tuned with the air filter in place, because it does make a difference. But since we'll be running this engine inside the shop, we really don't need an air filter at all. Depending on the application, well, the governor may not be necessary, especially on high-performance power sports stuff. I went the extra mile to get the governor to work because I need the automatic speed regulation for my experiments, and for me, a working governor is definitely necessary. So just for fun, I'll show you an example of what happens when you don't get the geometry of the linkages correct. Now, as you can see, we have a massive amount of hysteresis. So to the trained ear, it may sound like the engine's running lean, but that's not the case. The mixture's perfect. The hunting is because this metal rod is a bit too long. The tachometer numbers look okay, but you can definitely hear the governor struggling to regulate the engine speed. Well, thanks for sticking around to the end of the video. This was a fun project, and now that I have a fully adjustable ignition system and a fully adjustable carburetor, I'm looking forward to some wacky experiments. Hopefully, some of what you saw today will help you out with one of your projects. We'll see you next time. Until then.